Yeah, good evening all. Calculate current flowing through 3 ohm resistor here by using mesh analysis. Okay, in mesh analysis step 1 we need to identify the number of closed paths, right? One closed path, two closed paths, right? Okay, assign current direction I1 and I2, right? Assume loop current direction always in clockwise only, right? Okay, I1 direction is in clockwise and I2 direction is in clockwise, right? Okay, based upon this I1 direction, polarities will be across passive elements clockwise plus minus. Okay, similarly for loop 2 also clockwise plus minus. This is active element, again this is passive element plus minus, right? Okay, that is about polarities, right? Now apply KVL to loop 1. This is loop 1, right? Okay, when we consider loop 1 current magnitude is greater than loop 2 current. Okay, that is for minus plus minus 35, for plus minus plus. Here KVL, right? Algebraic sum of all voltages in a closed loop is equals to 0, right? Voltage is nothing but current flowing through that branch, that is nothing but I1 into 3 plus minus again plus 2 into I1 minus I2. Why? Because we are considering loop 1. Okay, if we simplify this equation, 3I1 plus 2I1, 5I1 minus 2I2 is equals to 35. Assume this is as equation number 1. Okay, similarly apply KVL to loop 2. Okay, then for plus minus plus 4 into I2. Okay, plus minus plus 40, again for plus minus plus 2 into I2 minus I1 is equals to 0. First write I1 terms, that is minus 2I1 plus 6I2 is equals to minus 40. This is equation number 2. Okay, while solving equation 1 and 2 in calculator, you will get I1 value as 5 amperes and I2 value as minus 5 amperes. Okay, here my aim is to calculate current flowing through 3 ohm, right? Then current flowing through 3 ohm resistor is nothing but here I1, that is current flowing through 3 ohm resistor is I1, that is equals to 5 amperes. Suppose in the examination he is asking to calculate current flowing through 2 ohm. That means either I1 minus I2 or I2 minus I1. But see here, if we simplify current flowing through 2 ohm resistor is I1 minus I2, that is 5 minus minus 5, that is 10 amperes, right? Positive value is nothing but, then current flowing through 2 ohm resistor is I1 minus I2. If you consider I2 minus I1, that is negative, right? Okay, current negative indicates assumed direction is reverse. Hence, the current flowing through the 2 ohm resistor is I1 minus I2. Okay, always positive value only. Okay, next problem. Calculate current flowing through 5 ohm resistor, again by using mesh analysis. Same here, identify the number of closed paths. 1, 2, right? Next, assume loop currents I1, I2 and assume loop current direction always in clockwise. Okay, based upon this current direction across passive elements, polarities will be plus minus for loop 1. Similarly for loop 2, plus minus. This is the active element, no need to give any polarities, plus minus for passive element again. Okay, based upon those polarities, okay, now see here you can apply KVL to loop 1. What you will get? Minus 30 plus 5 into I1 plus 10 into I1 minus I2 is equals to 0, right? Okay, first write I1 terms, 5I1 plus 10I1, 15I1. Okay, minus 10I2 is equals to 30. Assume this is as equation number 1. Next, apply KVL to loop 2. Okay, when we consider loop 2 current magnitude is greater than loop 1. Okay, then for loop 2 20i2 plus minus, here minus plus, right, minus 15, again for plus minus, plus 10 into i2 minus i1 is equals to 0. First write i1 terms, minus 10 i1 plus 30 i2 is equals to 15. Okay, by solving equation 1 and 2 in calculator, you will get i1 value and i2 value, right, in amperes. Okay, then current flowing through 5 ohm resistor will be i1, that is you will get i1 value here. Okay, in this way you can calculate current flowing through any branch. Okay, similarly you can observe this problem. Calculate current flowing through 11 ohm resistor. Okay, step 1, identify the number of closed paths, right. Okay, loop 1, loop 2. Okay, based upon this current direction across passive elements, polarities will be plus minus, plus minus, plus minus, right. Similarly for loop 2, plus minus in clockwise, plus minus. Okay, then apply KVL to loop 1. Okay, in this loop 1, I1 magnitude is greater than I2, right. Okay, that is from loop 1 for minus plus, minus 20 plus 2 into I1 plus minus plus 4 into I1, again for plus minus, plus 11 into I1 minus I2, again here plus minus. Okay, that is plus 30 volts. Okay, again here it is, again here plus minus, that is plus 6 into I1 is equals to 0. Okay, if I simplify this equation, 2i1 plus 4i1, 6i1 plus 11i1, that is 17i1 plus 6, 23i1 minus 11i2 is equals to minus 10. That is equation number 1. Okay, similarly apply KVL to loop 2. Okay, here plus minus plus, suppose here I can start from here for minus plus, minus 30 plus minus 11 into I2 minus I1 plus minus plus 6 I2 plus minus plus 10 is equals to 0. That is first write I1 terms, minus 11 I1 plus 17 I2 is equals to 20. Okay, by solving this equation 1 and 2, you will get I1 value as 0.18, I2 value as 1.29 amperes. Okay, in this way you can calculate problems on mesh analysis. Okay, thank you all.